A small garden center propagates tulip bulbs. The gardener begins with 100 bulbs. Each bulb produces several new bulbs. 3 of these are kept for the next round. Write an equation to represent the number of new bulbs. So, what's our scenario here? What do we have? What are we starting with? We're starting with 100. Yeah? And then what's happening after that 100? So they're going to make flowers, they're going to make bulbs. What's going to happen? Increase by 3, so it's 103.
No, it's 100
times 3. So each bulb is going to make 3. Right? So how many bulbs do I have in the second round? 3 of them are kept. 3 from each bulb. So, small garden center propagates tulip bulbs. The gardener begins with 100 bulbs. Each bulb produces several new bulbs.
Yeah.
3 of these are kept for 3 from each bulb are kept for the next round. Okay? So, basically, the one bulb is going to produce many bulbs. Right? But we're only going to keep 3.
Again.
You get it? So we're only going to keep 3 from each bulb. Okay?
Why?
So, because that's what they want to do. I don't know.
Why?
You can ask the gardener. I don't know, not me. Okay, so we know that after the first round, what's going to happen? How many bulbs am I going to have? So I'm starting with 100.
Okay.
I'm going to go to 300. That's after my first round, right? Then from 300, what do you think is going to?
900.
900, because each one is going to produce 3.
3. Okay.
3 times 300 is 900. So what's happening here?
It's doubling.
Doubling?
No, tripling.
Tripling,
Yeah.
right? So what? Basically, start with the initial number of bulbs. Okay, so the initial number of bulbs is 100, right? So that's before we even do anything. So that's at time 0, right? Before any round, you have 100 already exist. Okay? Then multiply by the growth factor for each round. What's my growth factor here? 3. So my growth factor is 3 because I am keeping 3 from each new bulb. From each bulb. I'm keeping 3 new bulbs. Good. So, my first round, how many bulbs did I have? 100. After my first round, how many do I have? 300. Right? So I multiply the 100 by 3, I get 300. I'm going to write that. Okay. The second round, what do I have? 900, right? So I'm multiplying this by 3, right? The 300, I'm multiplying it by 3. Look what I'm going to write though. Instead of writing 300, I'm writing 100 times 3, right? Which is this.
Okay.
And then multiplying it by another 3.
Oh.
Right?
This is 300 times 3.
Which is 300 times 3. But how else can I write it? 100 times
100
what?
Times the things where.
Yeah.
I mean, cube.
Cube.
No.
I mean,
3.
3.
Power
Yeah, power 2.
That's
That's
right.
it, sorry.
Because I have 2 3s.
Yeah.
Right? I will show you why I'm doing this.
Oh yeah. We did that before.
That's right. Then for the round 3, I have 100 times 3 times 3 times 3, which is what?
Which is 103 power of 3 again.
Yeah.
2700.
So what do you think your formula would be after n round?
Y equal
Y equal
to
to
the power of n.
Of n in this case. Yeah. Yeah. Okay? So if you have 10 rounds, the way to calculate it is 100 times 3 to the power of 10. Right? Do
Okay.
you guys understand that?
So the power is the round.
The power is the round, that's
Okay.
right.
Okay.
That's right. Because after the third round, the first round, I have times 3 to the power of 1.
Mhm.
After the second round, I have 3 to the power of 2.
Yeah.
Third round is 3 to the power of 3.
So-
Fourth round is 3 to the power of 4.
Is that your issue, man? What's the point, man?
So, remember I told you that sometimes it's not only y equals b to the power of x, it's y equals a times b to the power of x. What's my a value here? 100. Right? Because I'm starting with 100. I'm already there. I'm already at 100. Right? So this is what we call the generalized form. A is your initial value. So what you're starting with. What do we call B?
In this case?
What's B? That's your base, your growth factor, right? Common ratio. Okay? So it's your base. It's called the growth factor because it's a growth in this
Growth,
case,
okay.
right? Or it's your common ratio.
So if it's decaying, it's decay.
The decay factor. Yeah?
Okay.
And y is the value of x periods of exponential growth or decay. So y is your answer, and that's the value that you're gonna get at the end after so many decays. Exponential growth or decay. So the equation for this example is y equals 100, because that's my initial value, times 3 to the power of x, or n. Okay? Now, in this case, we know what's our growth factor. We know it's tripling, so that means it's 3. Or it's doubling, that means it's 2. But sometimes, let's say when you're going to the bank, okay? And in the bank, you're putting your amount, you're putting a certain amount, $1,000 in the bank for, and then they're giving you 10% interest. Dream on, but they're giving you 10% interest, right? So your amount is going to be growing, correct or no? Yes, right? It's going to be growing by $10, right? Every time. Good. Now, how would I put that in an equation?
What again?
Y equals 1,000
Mhm.
to the power or negative.
Okay, so here is the question. Good, so you know that we're starting with 1,000 and that's your initial amount, and that's gonna be the y equals 1,000 times something to the power of how many years you're gonna put it in, right? Now my question to you, is it a growth or a decay? Growth, because your money is growing, right? Good. It's growing by 10%. What's 10% in decimal?
1/10.
What's that? Yeah, which is 0.1, right? Okay, if I put 0.1 here, is that a growth or is that a
No,
decay?
that's decay.
It's a decay.
That's between 0 and 1.
So,
You have to put it back, right? Put 1/10.
1/10 is 0.1.
Same thing.
Same. Okay? Now, to make it a growth, we add 1. So it becomes 1 plus your rate. So the formula for something like this, where you have a growth rate, but you don't know what your growth factor is, you do y equals your initial, so your A value, 1 plus your interest, okay, which is in this case it's 0.1, to the power of how many years you're doing that. Okay? Now, if it's a decay, so if it's you're decaying, so it's, let's say you bought a car, you bought it initially for $20,000, and then every year you're losing 10% of its value. You're losing, right? So it's depreciating, it's decaying. Same thing happens, but instead of 1 plus I, it's going to be 1 minus I. So 1 minus the 10%, 1 minus 0.1 is going to give you 0.9. 0.9 is a decay factor. Okay? So this is the formula for growth. Okay? When you have, I missed to the power of 10. Okay? And the formula, if you have a decay, it will be y equals a1 minus I to the power of n. Okay? And I is your interest rate in decimal. You have to change it to decimal. So if it's 10%, it's 0.1. You divide your 10 by 100. Okay? These are the formulas. So you'll see them right here. Now, these are the formulas that I use for my grade 12, but they mean the same thing, right? Instead of y, I have an A, big A, which is the amount, equals to, A0 means initial, that's why we put the 0, that means at time 0, what's your initial amount? 1 plus I to the power of n, okay? And then for the decay, it will be A equals A0, again, that's your initial, 1 minus I to the power of n, okay? So they mean exactly the same thing, except instead of A, I used Y, instead of A0, I used your initial value K. Okay? Now the half-life and the double life, we don't do them here, but what you need to know is that half-life have a base of 0.5 and doubling have a base of 2. Okay? But we'll talk more about this next in grade 12. Okay? All right. Suppose you have $500 in the bank and you deposit it into a savings account that pays 2% interest per year. Find the equation that models this exponential growth.
Y 500 bracket 1
Yeah,
plus 0.02
that's right.
bracket 1.
To the power of n. I don't know how many years I put it in.
Is that 1 year?
Yeah, 1 year.
Just per year.
Per year.
Per year.
I just imagined it was 1.
Right? They did not tell us how many years I put it in. Right? So I leave it as that. Now, how do you get 0.02?
You divide the 2 by 100?
By 100. Because I have 2%, right? Which is equal to 2 divided by 100, which is 0.02. Excellent. So my equation is y equals 500, 1.02 to the power of n, because I added the 1 plus 0. Now my question to you, what's your growth factor? What's your base?
500.
1.02, that's your growth factor. Okay? Your growth factor, remember, is your B. Right? It's called the growth factor. Right? And it's 1.02. What's your initial? 500. That's what you're starting with at time 0. So that's your y-intercept. Right? Before you put the money in the bank, you have $500. So that's your initial amount. Yeah?
What did you do, 1.2?
1 plus 0.02.
Oh, it's 1, yeah, okay, gotcha.
Right? If I add these two,
Yeah.
I get
1.02?
Yeah.
Okay.
Now, The next question is asking you to find the amount of money you will have after 3 years.
Which is n is 3.
Exactly.
Yeah.
So you're gonna plug in 3 for n, and then you're gonna do it in the calculator. You're gonna plug it in.
$530.02.04.
530.076. Yeah. You got it.
Money should be left to 2 decimal place.
Oh yeah, sorry, 536.
30.60.
Yeah. And then it should be rounded to the nearest 100. That's it. Now, that means how much interest did you get in 3 years?
$30.
Exactly. Okay?
That's garbage.
What?
That's garbage. That's bad.
$30.60. That's what you usually, like, it's in 2% per year. Okay? Do you guys understand that? Do you understand where it's all like kind of coming together right now? Yeah? The base,
Money.
right?
Money, yeah.
Factor,
Money, I
growth
get it.
factor, is it growing or decaying?